Good morning. I'd like to introduce the first speaker in this room this morning. It's Andreas Ericcson from OP5, telling us something about what's new in Nagios 4. So,
right. Hello and good morning, everyone. I hope most of you slept more than I did. I actually spent till 6 o'clock this morning trying to figure out how to access the sound card on my laptop so that I could use it as an alarm clock. Not sure if that made much sense, but anyways. I'm about 32 years old. Actually turned 33 in a week. So yeah. Been programming since I was about 7. I work as a core architect at OP5, which means that I am basically a system designer and programmer, but I'm also banned from anything that has to do with UI design, because I really suck at that. I've been the Nagios core co-maintainer since 2009, and if you have more questions for me after my presentation, you will find me in the bar in the evenings. My presentation is pretty long already and pretty cramped, so if you want to know about OP5, I suggest you just check out that web address. My CEO usually sends me slides that I should incorporate, but they change every month, so not going to bother. What I will bother with, though, is Nagios Core 4. I'm going to be talking about the goals that we have for this release. We have to do a small algorithm analysis crash course so you can understand why some of the changes are done the way they are. I will show you a bottleneck analysis of Nagios Core 3 and the solutions we put in place for Nagios Core 4. Then I'll move into new features and then future possibilities. There are also a couple of slides about caveats and stuff at the end of this, but we might have to skip those. So the goals here is that we want something that is stable, scalable, and simple. In order to achieve that, we need to have something that is, well, low complexity in the stability layer. We need to have proper testing. For scalability, we need efficient, reusable, and well-tested algorithms that we actually can prove are the most efficient ones at what they do. We need to use the resources efficiently, of course. We have to have useful APIs, and we have to avoid magic at pretty much all costs. For algorithm analysis, if anyone has taken computer science, you will know that there are, you can hopefully know that there are a couple of different categories that algorithms can end up in. So if you have a sorting algorithm, for instance, you can run it optimally in this time. It doesn't really matter how much time is listed right here, but as you can see, the time increases with the worse the complexity of the algorithm is for even pretty small inputs. Here, this is just 100 objects. Constant time is, of course, it takes the same time no matter how many objects you put at it. And then it goes, well, gets worse pretty quickly there. So 2.96 times 10 to the power of 144 years. If you have 100 elements and each operation takes 1 microsecond. If you have factorial performance down here, not very nice. If we apply Moore's law to this, we can see that it will take a couple of 100,000 years before computers are fast enough to make even a dent in the gap between this algorithm and this algorithm. So if there is a faster algorithm, it will always be much better to use that than to just throw more hardware at it. And here you can see the growth rate from 1 to 10 of the various algorithms. These are the ones that are most commonly encountered in code when we're looking for objects or doing other things. Oh, that was a good one. Logarithmic algorithms, as you can see, they stay almost the same in size. They have about doubled from 2 to 10, but they won't grow as fast as the ones as the polynomial algorithms, which is the power of 2 algorithms. And what happens is that if you have 100,000 objects and you get over here, the time difference is huge. It's enormous. So big that it's not even funny to try to make graphs like this with large input, because only the biggest pillar will show up. I also had to do some media tests when I was doing the performance improvements in Nagios 4. And if you have a hard disk drive, this is actually state-of-the-art RAID 10 SCSI disks. They have a 5 millisecond seek time, thereabouts. The solid-state disk in my laptop has 0.24 milliseconds, and the random access memory in my laptop has 13 nanoseconds seek time. So solid-state disks are 21.3 times faster than SCSI disks in a RAID 10. ROM is about 400,000 times faster than SCSI, and ROM is 18,500 times faster than solid-state disks. So it's pretty easy to see here that all types of disk access that is done repetitive, that is done often, will kill performance outright. So for the test setup that I used here, I had 3,000 hosts, 200,000 services, 5-minute check interval, and a really, 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 really stupid plugin. It says everything is A-OK, and then it exits with 0 for return code. That's a bit silly because it won't behave like that in a real network, but this is just to test the throughput of the algorithms in Nagios core, not the throughput of the plugins or the network or whatever else they're using. So the bottlenecks that we found in Nagios 3, configuration parsing, that became apparent immediately because I could barely start Nagios 3 with large configurations. Event queue insertion, this is where the algorithm analysis crash course comes in. If it runs in linear time, which means that time increases linearly with the number of objects, this runs a lot for my test setup, almost 700 times per second. But the lowest bound is a logarithmic function. A logarithmic function of 700, well, of my 200,000 events is only like 15. So that's a lot better. Macro resolution was also a big problem. We used to issue about 3,700 string comparisons every second just to handle checks. That's retarded. And job spawning and check creeping. It's heavy on cache line fields and disk I/O, so we go to the disk all the time. And as you could see in the earlier slides, the disk access is bad. There was also insufficient parallelization in that only one check at a time could be spawned. So we can only create one check at a time. I think this is valid for Zynga core as well. I have no idea how much they've done with that. The Nagios 3 check flowchart works a bit like this. So Nagios reads the scheduling queue, forks a child, and on the right side here is what the child does. On the left side is what the main Nagios process does. And if we turn it like this instead, you can see that the red areas are where we access the disk. The yellow areas are where we do memory intensive and CPU intensive system calls. So this is not really stellar. So the config parsing, this is quite interesting actually. We use a depth-first search for host and service dependencies. If Sean Gabes is here, raise your hand so we can like. Oh, he's not. He's coming tomorrow. He did that for host parents for both Nagios core and the Zynga, I think. The point is that we move from a polynomial algorithm, which is basically power of 2, to a linear algorithm. So for 20,000 dependencies, we move from 400 million operations to 20,000. This is usually where large systems that have a lot of dependencies, they would get stuck here. They would take forever. One guy who's in the US who helped me test this, he had 227,000 dependencies. And we had to do some basic math to figure out that his configuration would complete validation in about 4,000 years. It's not really nice. So with this patch instead, it runs in about 1 minute and 50 seconds. It's still a long time, but a lot better. Group members are no longer duplicated. They could be before. If you look in objects.cache, you will see that the same member is listed multiple times. We verify things exactly once, and the effect is that Nagios loads configurations really, 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 really fast. Typically, configurations that took a minute or 5 minutes or 3 minutes or whatever will load in a few seconds, 1 second, sub-second. It actually interestingly now, it loads faster if you have services on host groups, for instance, because then we just copy them in memory instead of where we used to copy every string for them. The event queue. We move to a priority queue based on a binary heap. This turns insertion of events from a linear algorithm to a logarithmic algorithm. It turns extraction of events from a constant time algorithm to a logarithmic algorithm. I was a bit worried about this because going from constant to something worse is usually a bad idea. But it turns out that we're going from 43 million to 9,460 operations, and this is per second in my test setup. So usually you would see Nagios or Ericcson is keeping one CPU pegged at absolute maximum, running one CPU at 100% if you have a large network. That's just to handle the event queue. That's only to handle the event queue. The effects of this is that the main Nagios process uses a lot less CPU. I have a hard time getting it to rise above 5% from one CPU. The priority queue used here is the same that is used in Apache. The author, Volkan Yasici, is naturally credited here. For macros, we sort macros once on startup. We could actually move them to a hash table instead, which would turn this into a constant time lookup. But I do some special tricks for like the user macros and the numbered macros and host address, which are present pretty much everywhere in all commands. So we move from about 65,000 operations down to 3,000 per second. So this is a really simple fix. So we could cache resolve check commands as well to make the trade-off between processing time and memory, and then this would all be instant time as well. I haven't bothered though because it doesn't seem to be a bottleneck right now. Check solutions. This is the big one, which I've been working several months on. Worker processes take care of running all the helper apps. The helper apps are, for instance, plugins or notification script or event handler scripts or whatever scripts, performance data scripts. One interesting thing here is that the worker processes are pretty small. And I hadn't really counted on this, but the number of forks we can do per second increased a lot. If you have a 300 megabyte process, which is what we get when we load 200,000 services into Nagios, we can do 800 forks per second. If the process is 1 megabyte, we can do about 14,000. This is the hard cap for how many checks a system can run. If you can't fork fast enough, you can't run enough checks. There's no way around that, really. This is also a bit murky in the kernel because unless you have NUMA CPUs, you can't fork more than once at a time. It's a little bit weird. But the effects here, anyways, is that we drastically reduced the I/O load from about 100% from handling all the check result files down to, well, nothing. It's weird. The only I/O that Nagios generates now is when it writes its status log file, which you can disable nowadays, and when it writes its regular log file. So, you could run it off a Raspberry Pi if you like. It's not going to matter. We can also run up to 300,000 checks every 5 minutes. That's with my check AOK plugin. I tried it with 700,000, but then it bombed out on me, and I was on my way to the airport. This was actually 6 weeks ago, so I should have done my research better by now, but I'm very lazy. Kudos here. Sven Nierlein, who I know is sitting somewhere here. William Leibson and Sean Gabes. These are the guys that proved early on that having separate workers is a better idea than trying to fork it from Nagios itself. Because those of you who have tested Mod Gearman, for instance, with Nagios, know that even if you run all the Gearman workers on the same server, you get a lot better performance than if you just use Nagios itself. So, kudos where kudos are due. Worker processes. They are spawned by Nagios. Actually, Nagios forks, and then it executes itself with a ---- worker. They're chosen in round-robin fashion, so the workers are just, we take one and then the next one. They communicate with Nagios using libnagios APIs exclusively, which means that all of the code in the workers is tested. The to-do here is actually not really to-dos anymore. Special purpose workers can call in and say, hey, I will take care of all the checks for this plugin. Then Nagios will feed checks for that particular plugin to that particular worker. You can have several workers sharing the load for the same checks if you like. And this is very useful for agent-based checks, for instance, where we no longer have to fork at all. So check NT, check NRPE, check SNMP, I have no idea. It also means that you can write workers that cache data for itself. So you can cache the entire SNMP tree of one device every minute if you get a request for it, and just refresh it if it gets stale. Remote workers, that's also sort of implemented. The only thing you need to do is export a socket via xenitd from Nagios. So anyways, the Nagios 4 check flow chart looks like this. It's pretty much nicer, all right? If we have special purpose workers, it looks like this. The special purpose workers can do voodoo, and voodoo can be either good or bad. It depends on the person. So if we compare this with Nagios 3 flowchart, you will see immediately that it's a pretty huge improvement, actually. So if we run the check engine performance comparison, this is with test that Sean Gabez himself used, and I used the same figures that he did. Centrion has managed to reduce the performance of Nagios somehow. Isinga Core claims to run about 31,000, whereas Nagios 3 runs 30,000. The green pillar here is Nagios with Gearman. The brown one is Schinken, and the blue one is Nagios 4. So I win. New features in Nagios 4 is libnagios, which is not so much a feature as it is a library that Nagios itself uses, but it's exported to help add-on development. There's also a query handler. There's the Nagios event radio dispatcher, NERD. We've implemented service parents, which one service can be a parent to another to help with service dependencies. There's also something called hourly value and minimum value and check source. It's pretty nifty. I'll go into further detail here. libnagios, well, lots of stuff here. Use it if you want to. Just link to it. One usage example. This is actually a program that I'm using more or less constantly to just debug the query handler. Oh no, this is for a demo I'm going to show you later. So query handler is a general purpose handler for addressable queries. It's pretty ridiculously simple, actually. So you start with an @ sign. You say, this is the address I want to talk to. This is the handler I want to talk to. You put a space after it. The address can't have spaces in it. Then you write your query, and you end it with a null byte. So the echo service is built in. That is about the only one. Actually, the NERD service as well, it uses the query handler. You configure it like this. Path to nagios.qh. If Nagios can't write to its own query handler, you will be in trouble with Nagios 4. Kudos for inspiration here, Matthias Kettner. This is obviously inspired from his live status, which just answers questions on the fly. I wanted something similar for Merlin, so I built it right into Nagios, and now Nagios has it for itself, so you can get status, like check stats and stuff like that from things there. The NERD radio, Nagios event radio dispatcher, provides real-time data to outside add-ons. That's the goal and purpose of it. It can reduce the I/O load of current add-ons, so you can stream things instead of just parsing a log, or you just say, oh, hey, I want to listen to everything that comes here. And then you stream it off to somewhere else. So if you have, I don't know, Tivoli or some other monitoring system or a ticket system, you can just stream everything there. You query it as NERD via the query handler. So example queries look like this. nerd, subscribe, host checks, where host checks is a nerd channel. To do, I still haven't added macro support, and I'm supposed to add an alerts channel as well. But so far, you can already do pretty cool things with it. Observe. Swing. This is actually Nagios Core 4 with its workers, and this is produced in real time using GORS, which is actually a software version history visualizer thing. And the network map is drawn from the actual topology of the network that we're monitoring here. This is for about 2,500 hosts and some 30,000 services, I think. And this is written using the nerd radio. So we sign in and say, hey, give us all the checks that you're running. I think host checks are the white ones and service checks are the yellow, but I'm not really sure. It's pretty nifty, huh? Who wants it? I so very rarely get to demo things, so. Oh. This is I'm not sure if you can see this properly, but echo, hello OSMC. So that's Nagios saying hello to you guys. This is the query handler in action. I just wrote a small program that sends whatever I type just into the socket when I type two carriage returns. And then Nagios will echo that stuff back to me. If I want to subscribe to the channel that, oops, checks. This is the channel that I'm using to generate that map. It's built into Nagios. It wasn't supposed to be, but I messed up when I committed and it got turned in. And then people started wanting it, so yeah. So that it's really a simple thing to work with, and it can be useful. There are no real uses for it yet, except to get a few ooh and ah from presentations, which is nice. I very rarely get to do visual demos. Other features, service parents. It's basically service dependencies made easy. One service depends on another. For Nagios 4, I was asking people to send me lots of configurations so that I can just see how they worked and see how configuration parsing would turn out, make sure that there aren't any bugs in it. Turned out that there were a lot of service dependencies. Almost all of them were of the kind, oh, hey, we check the version of this agent, and then we let all the checks that go through that agent depend on the check that checks the version of the agent, basically. And the version check is just a, hey, can you take our query and respond to it? Hourly value and minimum value. The use cases here are a bit vague, but since I only have like 3 new features, I thought I should add some more. The idea is that you can set hourly value for your services or for your hosts, and they will get, then you can filter your alerts or filter problems based on the hourly value so that you will know how much a particular problem is worth in your network. So if you're running if you're Amazon, your web shop might be worth $200,000 an hour. Then you set 200,000 here. Or if you're managing printers for an internal company, then you set, oh, this printer affects 18 people. This printer affects nobody because I just use it to test things. And then you can set your hourly value any way you like, really. The minimum value here is something that you can configure for contacts. And if the hourly value does not exceed the minimum value, or does not tangent or exceed the minimum value, then nothing happens. The defaults for these are set so that if you don't touch them at all, everything will work the same way it always has. Minimum value is 0, actually 1 by default, and hourly value is also 1. So if you set it to 0, then your notifications should be suppressed. It could be useful if you have development equipment, for instance. Then you want to make an easy switch for them to production. Check source. This became increasingly difficult for our customers at OP5. We also write something called Merlin, If you don't know about it, look at that OP5 thing. It's designed to be able to do high availability and load balancing and redundancy. But it turned out that it was really tricky for our customers to know where a check was executed. Now that's positively trivial. This is supported in mod German as well, I know, so that if you have remote workers in German, for instance, or pollers in Merlin, then you get to see which node actually executed the check. Pretty useful. You can also run make docs and look in documentation. I'm going to do that now. And this is why we could skip most of the... I do not have a browser. Wow. I don't think that's ever happened to me before. Right. If you know about Doxygen, you will know that you get documentation like this, this has incompatibilities for the API, configuration incompatibilities, list of the query handler, which I actually haven't committed yet, but it gets generated here as well. And the files list contains all the stuff that you will find in libnagios. It's pretty easy to use. How am I doing on time? I'm ahead of schedule, am I? Easter eggs and micro features. The dev null hack. If you set object cache file or status file to /dev/null, Nagios will just return from whence it came when it tries to write them. This is useful if you're, for instance, using live status to get current status out of Nagios. Otherwise, you could do this. You could have done this before as well, but then Nagios would actually iterate through all your objects and then dump them into the kernel oblivion, which is dev null. Now it just doesn't do that anymore. There's a Nagios devel package available, which is libnagios and the Nagios core headers. This is not a major thing, but it's very, very handy for those of us who write event broker modules, because we used to have to carry them around with us. Now we can just say that you have to install this package. It's very nice. For the add-on status, mod German, mod PNP, live status, and Merlin. Actually, live status from our repository, my repository, works. I haven't talked to Matthias Kettner in a few weeks, but it's working. And Merlin is as well. I went to the Nagios World Conference in September, and I helped a guy named Eric Stanley, who works for the Nagios Enterprises, to port NDO utils as well. So if the IDO utils maintainer wants some help there, I think you can look at the code from NDO utils. There are a couple of known bugs, of course. Host latency calculation is for some reason messed up. I am not sure if that's because host checks are scheduled multiple times or what's happening there. If use aggressive host checks equals 1, if that's set to 1 in Nagios configuration, on-demand host checks are still run in a serial fashion. And environment macros are currently not supported. It means that macros have to be passed for 2 commands on the command line. I'm actually a bit reluctant to support environment macros again, because doing so means that they have to be calculated every time. That takes a long time for most of the checks, and it will lower your performance significantly. They also don't play nicely with, for instance, well, live status, and I know a few other modules that have problems with them as well. So they're a bit of a not so nice can. Deprecation notices. This is what you've all been waiting for, I know it. From command line, if you, the -O flag, don't verify objects, it's removed. It was never in the help output, and it was just a hidden feature. It's gone now. It will throw an error. There's no way that we can not verify objects, because we already do that when we look things up. Don't verify object paths is deprecated and will produce a warning. This is because it's now so fast that that flag doesn't really make sense. Object configuration in nagios.cfg is now officially unsupported. Do not rely on it to work. It used to work a little bit for someone who sent an email to the list and said, hey, you broke this in Nagios 4. And I said, wow, sorry. Instead of trying to figure out how I broke it, I decided to just officially unsupport it. Embedded Perl has been removed. There are too many reports on memory leaks that we really couldn't track down. It was impossible. One strange thing here is that performance improved in workers by removing it due to the smaller memory footprint. So the case where you have 50% of your plugins in Perl and 50% in every other language combined, you would still be at a break even just by removing embedded Perl because check execution is a lot faster for small processes. Bit weird, but there you go. Sleep time. Nagios is, the major change is actually that Nagios has been turned into an event engine where you can either start an event or receive an event. So sleep time doesn't really make sense because we just wait for the next event to happen if we have nothing to do. Command check interval. A command is just an event, so we don't check for them periodically. They're always handled on arrival. Last command check, same thing. Failure prediction was never implemented. It's been in the code as a variable that we've been carrying around since 2002, but it was never properly implemented. It was grand plans to handle that, but no. And of course, everything relating to embedded Perl. For objects, failure prediction, again, never implemented. Group member exclusions are no longer inherited by group in-group inclusion. Does that make sense to you guys? Well, it took me 5 hours to track it down, so if it takes you 3 minutes to comprehend it, I'm not going to cry over that. The example here, I think, describes most of it. If you have one group with members A and B, and group 1 includes group 2, if group 2 excludes B but includes C, then in Nagios 4, group 1 will have A, B, and C as members because the explicit inclusion here trumps the exclusion from here. We no longer inherit exclusions, basically. In Nagios 3, it would be A and C that were the members. This really surprised me, actually, because I thought I was creating a configuration that had a lot more services than it did. But I started off with a configuration that someone sent me over the network, and I was like, what? The math didn't add up, and trying to debug a configuration with 450 service groups and 36,000 services, it was not so fun. Special thanks. Ethan Galstad, Daniel Wittenberg, Armin Wolferman, Jörg Linge, Sven Nierlein, Mark Frost, Robin Sonnefors, William Leibson, and everyone who sent me configs for testing. I know that Jörg is here today. I know that Sven is here as well, somewhere. Can we just give them a round of applause for testing and patches they sent me? Very many thanks, guys. Oh, wow. I've been doing this presentation in about an hour earlier, but seems I managed in 35 minutes now. You can look me up between sessions. I will actually, since most talks are in German, and I speak German only when I've had at least 4 beers, I will probably be wandering around the hotel most of the time. What? You can also check out the Make Docs thing. It will answer most of your questions, I hope. If there are any more questions, just come and ask me, and I will add them to the documentation thing. The online resources, you will want to see github.com/ageric. That's where we put, if we need to port something to work with Nagios 4, it will be there. Also, op5.com will have a link to op5.org, which is where we stash a lot of code. So, questions? Wow. Must have explained everything brilliantly. Yes?
Is Nagios 4 still in beta status?
Yes, it is. The current Nagios 4 is still in beta status. The current version I think I decided on was 3.99.96, something like that. Before it says 4.0, it means be a bit cautious. I'm at OP5. We're supposed to build a beta for external testing with monitor 6, which will contain Nagios 4, and that's due out next Friday. So we have about 8 people running tests in our lab right now. So the versioning, I just haven't bothered to update it, basically.
I've seen your subscribe channel for the live status thing, where you can get information from the Nagios core. Which output format do you use? Maybe an XML, stuff like that?
Yeah, right now I'm using a ridiculous output format, which isn't really supported. The question was for benefit of a video thing. Output format supported in the Nerd radio. So right now I'm not really supporting any output format at all. It's just debug output basically. The idea is to support macro substitution in the output, and then you can have then you basically can build your own if you want JSON or XML or whatever. Yeah, it's also the idea is more with the Nerd radio as well as the query handler is more to provide the interfaces so that you can write your own event broker that says, oh hey, I'm going to take care of this radio channel now, and then you can format your data any way you like inside your own event broker module. So you can register for channels with the Nerd radio, and you can register to take care of queries with a query handler. If you try to register the same address or the same channel that already exists, you will get an error. So it's so long as you don't clash it, but don't call your channel X. It should be. It's a big namespace. You can use whatever names you like. More questions?
Are there some of the performance improvements available for Nagios 3?
Not really, no. I could backport the configuration fixes. I could backport the event queue, but backporting things means basically bringing in all of libnagios as well, just putting it on top of Nagios 3 and then rewriting a lot of stuff. So in terms of code changes for the core, it's about 35% that has been rewritten completely. So backporting things is going to be difficult. The things you could do is macros would be pretty simple, but that's the smallest part of it. You could also, the scheduling queue would also be pretty simple. Other than that, it's not that much to. The biggest change is the worker processes, and that's a huge fundamental change in Nagios. So
better wait for 4.
Yeah, exactly. Oh, one cool thing was that at the Nagios World Conference in September, there were actually 3 guys who used Nagios 4 in their demos live. I was really amazed. They also used the CGIs, which I haven't tested at all. But apparently they just kept on working. Good luck for me.
Any other questions here?
Screensaver time. Yeah.
You've mentioned that with Nagios 4 you can run the workers even on different hosts via xinetd. So where's the advantage of still using modgearman when you even can have multiple workers on different hosts with Nagios 4?
Well, modgearman has a slightly different architecture. It uses a Gearman queue, so it's a lot easier to, if you have huge networks, to just spin up, say, 100 Gearman worker servers or kick them off on demand without having to configure them based on anything else than the Gearman server, I suppose. But this turns into a bit of a conceptual issue as well. I always thought that one of the biggest reasons for adding event broker support to Nagios is that the great ideas, such as mod Gearman, live status, live query things, should be pulled into the core so that everybody can benefit from them. Because until they are in the core, not everyone will use them. So then you have add-ons using a hodgepodge or a mishmash of various data feeds. That means that some add-ons will suffer just because the data feed is bad. Like NDO utils can't keep up with Nagios 4 anymore because the transfer format is simply bad. So live status is the one I would recommend, and everybody who writes an add-on that wants to work and wants their add-on to work with both live status and Nagios and just vanilla Nagios have to take care of supporting the object cache file and the status log and the log files and whatever. So it gets tricky pretty fast. Whereas it would be better for the entire community if we could decide on a few APIs and then say, use this, and then people start building add-ons off of that. So the conceptually, mod Gearman is still, Nagios will never get a built-in message queue, for instance, that works on remote servers. So if you want to use that, then you should use mod Gearman. Mod Gearman is still an excellent piece of software, and I met several people at the conference in the US who have networks larger than, well, they're about the size of Germany, actually. One of them is The Gap. They have 3,600 stores with 20 to 50 servers in every store. Well, pieces of equipment that they need to monitor. And they also have, besides that, their own internal infrastructure. They do, just to save on power, they save about $10,000 every day from just shutting down one data center. When they do that, they take a lot of Gearman workers offline, and they just work. Because they don't have to check so much in the stores when the stores are closed. So when they start them up again, they just, oh, hey, I'm going to take the next work, the next job, the next one. And it's very easy to see that the Gearman workers are up and running if they just empty their message queues properly or refill them. So a lot of people are very happy with how mod Gearman works. It's actually quite a huge challenge to make something as good as that, even with remote worker support in Nagios. Because we don't have authentication or anything like that yet. I'm sure you could hack something up with Xfinity or something, but I'm not sure. Oh yeah. I'm gonna be there. Any more questions? Screensaver.
Just a short question. When will the Nagios 4 be stable? Is there any date, any plan?
Actually, it probably would have been already if I hadn't been traveling for the past 4 weeks. So, well, this conference included, I've been home 1 day a week the past 4 weeks. And the rest of the time I've been on the road. I told my boss that I should get a laptop with 7 hours battery time. That would also have made a difference. But the worker process code and everything related to it, well, most of the things related to it have been ready and working and just fiddling, just working as intended for a long time. I wrote large parts of it before the summer even, and those who were looking at my GitHub repository would have seen that the worker process code was ready a lot earlier than now, well, a long time ago. But it will still probably be a while. I can show you how it looks with if I spawn a second worker. But it will be very soon. Like I said, we're supposed to release a beta on Friday next week, so you can expect Nagios to be ready more or less by then. What? No. Well, didn't get much bigger. So if you look here now, it's a bit hard to see, but there should be 6 workers here. The number of workers is actually auto-determined, and I have 4 cores on my CPU. Well, counts as 4 cores for the Linux kernel anyway. So it will spawn 1.5 times the number of cores you have in workers. That's because the workers work as a sort of fan-out channel, and if you have only 1 worker and try to run 300,000 checks, it will get not good. The socket that is trying to communicate over will be congested almost all the time, and the buffers will just fill up, and then so we'll spend a lot of time doing that. So 6 workers for 4 cores is actually just a ballpark figure, but it seems to be working pretty nicely. If it's not enough, you can always fire up a new one, and we should see that one coming online here pretty soon. They have to do a little exchange and say, oh, hey, what can you do? What are you doing? Oh, and I should have added, oh, yeah, right. The rendering is lagging a bit because it can't really render in, oh, there we go, Core Worker 899. That's a new one I added just on the fly, and other core workers can just be added the same way, but Nagios would have to be taught how to speak network sockets, basically. It's really pretty quickly done, but still needs to be implemented. Look at the little lasers. Whee! Any more questions?
Yes, I have a second question.
Yep.
Will it be able to read the Nagios 3 configuration, except the Nagios config itself, but only the object configuration files?
Yeah, it will be perfectly capable of reading the Nagios 3 configuration. It will be the variables that I told you before are deprecated nowadays. They won't actually throw an error. They will just tell you, hey, this is deprecated. You should remove it before Nagios 5. So we have a really long deprecation time. If we think of when Nagios 3 came out, I think that was in 2007. So that means that in the next 5 years, you need to fix your Nagios configuration. Other than that, we just.
And the third and last question from my.
Yes.
Regarding graphing, will you use PNP or built in, or will PNP be an add-on in the future?
No, PNP will still be an add-on. What I'm working on and my primary field of interest is just the Nagios core, which is the scheduling engine, the how we run checks and stuff like that. Other people than me are writing plugins and visualization stuff and graphing stuff. I mean, it would make sense to have more Gearman-ish capabilities in Nagios core because it's such a very, very core feature, or live status feature inside Nagios core, because it's one way for checks to be executed or for add-ons to get information out of Nagios. But producing graphs and things like that, it's not really. That's what I would call feature bloat if we build that directly into Nagios. It would be one thing that you could do is just add a nerd channel that feeds performance data out to a remote thing that listens to it, and it would have to cache the performance data if no listener is available for a limited amount of time, maybe. I don't know, but that's just one way of possibly making PNP a little bit more efficient, and that's what I do. More questions? No? In that case, thank you for listening.
Thank you, Andreas.
Thanks.